Hey everyone, welcome to Pi by Pi, where we tackle IGCSE math one step at a time. In this video, I'm going to go through a predicted paper 2 for the upcoming exam based on topics that didn't show up in paper 1, which means they have a higher chance of appearing, though of course, nothing is guaranteed. The goal here is to help you practice the most likely questions and build confidence ahead of the real thing. So grab your calculator and let's get right into it. Let's look at the first question that is asking us to prove that 4 2 over 3 plus 3 4 over 5 would give us 8 7 over 15. Now we're dealing with fractions and we need to add these fractions. So one of the ways in which we do this is by making sure that we start by writing them down as improper fractions. So to convert any mixed number into an improper fraction, you start by multiplying the denominator by the whole number and then you add the numerator. So in this case, we'd be doing 3 multiplied by 4, which gives me 12. And then I add 2 to it, which gives me 14. So I'm starting off with 14 over 3. And I do the same thing for the 3 4 over 5, which now gives me 19 over 5. In order for us to be able to add fractions, we must ensure that the denominator is the same. Now, one of the easiest ways of finding the denominator if you're not comfortable with looking for the LCM is by simply using the butterfly method, which means I'm going to multiply 14 by 5, which is going to give me 70. And I also multiply the 19 by 3, which is going to give me 57. I've also multiplied my denominators to get 15, and that's how I went about it. Now I'm simply going to go ahead and add my numerators, which gives me 127 over 15. Now we had to show that it is 8 7 over 15, which means I need to reconvert this into a mixed number. To do that, we can engage in long division. And I know that 15 goes into 127 8 times to give me 120. When I subtract that, the remainder is 7. So this number on top over here is always going to be our whole number, which is 8. Whatever we have as the remainder is going to be our numerator, and the denominator stays the same. It was 15 and it remains 15, and hence we have proven that this indeed does give us 8 7 over 15. Alright, moving on to the next question, whereby we're being asked to look for the HCF, the highest common factor of 96 and 120. So there's multiple ways of doing this. I'm going to show you one way of going about it, and that is by using a table method. So we're dealing with 96 and 120. Look for a common factor of this. What is a number that I can divide both of them by and not have a remainder? So I know they're both divisible by 2. They look like they're even numbers, and so I'm going to divide them by 2. 96 divided by 2 gives me 48, and 120 divided by 2 gives me 60. Continue checking if there's anything else that's common between them, and again, I see that they are even numbers, so I can go ahead and divide by 2 one more time. When I do that, I'm going to be left with 24 and 30. We're not done yet. They're still even numbers, which means they're divisible by 2. And when I divide these by 2 now, I'm going to be getting 12 and 15. Let's confirm if there's anything else in common. I know that they're both divisible by 3. And so I'm going to divide by 3. 12 divided by 3 gives me 4. And 15 divided by 3 gives me 5. Now there is nothing left in common between 4 and 5. The question asked me to find the HCF, the highest common factor, and all I need to do now is multiply these numbers that I have on the side. So 2 multiplied by 2 multiplied by 2 multiplied by 3, which gives me my HCF as 24. Alright, moving on to the next question. This time round, they've given us A, B, and C written as products of their prime factors, and they are asking us to look for the LCM. Now, when you're asked to look for the LCM of such, all you need to do is start by looking for all the bases. So we're not going to look at whether all of them have a base of 2 or 3 or 5. We're going to take all the bases that you see. So currently I can see there's a base of 2, there's a base of 3, there's a base of 5, 7, and 11. Remember, this is because we are looking for the LCM. I know I'm going to be multiplying them. Now, when it comes to the powers, whenever you're looking for the LCM, you will take the highest power of each. So if I'm looking at the highest power of 2, I see that it is 4. The highest power of 3 is 1, so I can leave it without a power. The highest power of 5 is 2. The highest power of 7 is also 2, whereas the highest power of 11 is 1. And that there is our solution. Okay, let's move on to the next question. Question number 3. The diagram shows a triangle ABC, and you're being asked to calculate the size of the length of AB. Now, this is a right angled triangle, which means I can apply SOHCAHTOA. In order for us to apply SOHCAHTOA, the main thing is to know how to label our sides. So you should know that the side across the angle is always going to be our opposite. The longest side is always going to be the hypotenuse, and the remainder of the side is going to be the adjacent. Now the question wanted me to look for the opposite, and it had given me the hypotenuse, so that means I do not need the adjacent. I'm left with O and H, which means I'm going to be using SOH, S-O-H. And because I'm looking for the opposite, all I need to do is I need to take these two and multiply them. The S stands for sin, so we're doing sin 65 multiplied by the hypotenuse, which in this case is 8.4. And when I work that out, I'm going to get my answer to be 7.61. All right, perfect. Let's move on to the next question. This is a question on bearings, and you're being told that the bearing of Paris from London is 149 degrees. The question's asking you to work out the bearing of London from Paris. So what I like doing in such questions is making a sketch, all right? So we're being told that the bearing of Paris from London, which means we need to start at the north line of London. So I'm just going to make a sketch, nothing accurate. We're going to presume that this here is London, and the bearing is 149 degrees. So I'm just going to make that sketch and say this is my 149 degrees, and that takes me to Paris. All right, I'll have another north line right here as well. The question is asking me to work out the bearing of London from Paris, which means I need to start at the north line of Paris and move in a clockwise direction. This is what I am required to look for. Now, multiple ways of going about it. I'm going to go about one of the ways. I'm going to start by looking for what this angle here is. Now, because I'm dealing with two north lines, it means that these two lines are parallel to each other. Because they are parallel to each other, these angles are co-interior. So whenever you have the C shape or the C letter formed, you know that angles are co-interior, meaning this angle and this angle here are going to add up to 180. I've been given one of the angles to be 149, so I can do 180 minus 149 to find this angle that's within, and that gives me 31. So I know that this angle here is 31. Now to answer the question, I know that angles around a point add up to 360. So all that I need to do is subtract 31 from 360. And when I do that, I'm going to get my solution to be 329. And that's that question done. Okay, moving on to the next question. Anjali travels on the Eurostar train from Paris to Amsterdam. The distance the train travels between Paris and Amsterdam is 515 kilometers. So we've been given the distance to be 515 kilometers. The time taken to travel between Paris and Amsterdam is 3 hours and 18 minutes. We're being asked to work out the average speed, and we're being asked to give our answer in kilometers per hour nearest to the nearest whole number. So you should know the relationship between distance, speed, and time. And you should know that whenever we're looking for the speed, it is gotten by taking the distance divided by time. So based on the information, we know that the distance is 515. Now when it comes to the time, because our answer needs to be in kilometers per hour, the time also needs to be in terms of hours. What we've been given is 3 hours and 18 minutes. So I can write that down as 3 hours. Remember, I need to convert these 18 minutes into hours, so I can just do 18 over 60. Now with the help of my calculator, I'm going to divide this and I'm going to find my solution to be 156.06. The question wants it to the nearest whole number, and so my answer is going to be 156. All right, moving on to the next question. Here are the first 5 terms of a number sequence: 7, 11, 15, 19, 23. You're being asked to find an expression in terms of n for the nth term of this sequence. Now there's 2 ways of going about this, and I'm going to show you both the ways. The first way, the most common way that students do know of it, is using the formula method, which is gotten by a plus n minus 1 d, where a refers to the first term of the sequence and d refers to the common difference. So based on the sequence that has been provided, the first term is given as 7, n minus 1 remains n minus 1, and the difference is what you're doing to get from one term to the other. In this case, we see that we are adding 4 each time. We're adding 4, which means the difference is a positive 4. So this is what's going to give me my nth term. I can decide to go ahead and expand my brackets for n minus 4 and then collect my like terms to get 4n plus 3 as my answer. So this is one of the ways of going about it. The second way of going about it is simple. You don't need to memorize this formula. You start by looking for the term to term rule, which we mentioned earlier is the common difference. In this case, we're adding 4. So I'm going to use 4n. And then you look for a number that would appear before the 7. So if you were going backward, you would be subtracting. So 7 minus 4 gives me 3. It is a positive 3. So 4n plus 3, which is the same answer that we had earlier. So use whichever of the 2 methods, you'll always get the same answer. Alright, moving to part B of the same question. You've been given the nth term of a different number sequence as 80 minus 2n. The question is asking you to write down the first 3 terms of this sequence. So when n is 1, when n is 2, and when n is 3. I'm going to start by substituting 1 to find my first term, and that's going to give me 78. Then I substitute n to be 2, it gives me 76. And then I will substitute n to be 3 and it gives me 74. So that's done. The following question says, Yuan says that there are no numbers that are in both the sequences, and he's correct. You're being asked to explain why. So if you compare the 2 sequences that we have, you notice that the first sequence was made up of odd numbers, whereas the second sequence is made up of even numbers, and so he is correct because sequence 1 has odd numbers, whereas sequence 2 has even numbers. And so we will not have a number that is common in both the sequences. Moving on to the next question. This is a question on probability. A bag contains only red beads, blue beads, green beads, and yellow beads. The table gives the probabilities that when a bead is taken at random from the bag, the bead will be blue or the bead will be yellow. The probability that the bead will be green is twice the probability that the bead will be red. Okay, now I haven't finished reading the question, but whenever it comes to word problems, students often get very put off when they see too many words in a math question. So remember to take it one step at a time. For every statement that you read, see if there is anything you can fill in. So the information is telling us the probability that the bead will be green is twice the probability that it will be red. Alright, do we know the probability that it will be red? We do not know that. So I'm going to give it an unknown. I'm going to call this x. And green is twice the probability, which means green is going to be 2x. I've used that piece of information. Let's continue reading the question. Sophia takes a bead from the bag at random. She writes down the color of the bead and puts it back into the bag. She does this 180 times, and you're being asked to work out an estimate for the number of times she takes a red bead from the bag. Right. This means we need to start by looking for the value of x. Now, you should know that the sum of probability is always going to be 1, which means that if I take x and add 0.24 to x and 0.31 to it, the sum should give us 1. Now, I collect my like terms. X plus 2x gives me 3x. 0.24 plus 0.31 gives me 0.55, and this is supposed to equal 1. I'm going to go ahead and try solving this. I move the 0.55 onto the other side, which means I'm doing 1 minus 0.55, giving me 0.45, and then I divide both sides by 3, and that tells me x is 0.15. So the question wants us to find the number of times she takes a red bead. We already know that red was given as x, and the probability we found is 0.15. So because she's doing it 180 times, all you need to do is take your probability and multiply it by the number of times she does this exercise, which is 180, and it is going to give you a solution of 27, which means the probability that the number of times she's going to take a red bead is 27. Okay, moving on to the next question. ABCD and FGHI are parallel straight lines. EBGJ and ECH are straight lines. BE equals to CE. Angle BEC equals 44, which is all marked on the information. Work out the size of angle GGH, and you're being asked to give a reason for every stage of your working. All right. Now, don't only focus on what the question's asking. In such a case, always try and look for whatever you can find. So, I'm going to start by focusing on triangle EBC up here. And you see that it has been marked for us as an isosceles triangle. Now, because it is an isosceles triangle, I know that the base angles are equal. Additionally, I know that angles in a triangle add up to 180. So from the 180, we've already been given the 44 degrees. So I'm going to subtract that, and it gives me 136. Now base angles are equal, so this 136 needs to be divided equally into two parts to give us 68. I know now that this particular angle here is 68 degrees. What else can I find? Well, I know that EBGJ is a straight line, and we know that angles on a straight line add up to 180, which means these need to add up to 180. From the 180, we've already been given the 68 degrees, so I need to subtract 68 from 180 to find what this particular angle over here is going to be. When I do that, I'm going to get 112. Now, because I know we're dealing with some parallel lines, there are some things we can look out for. We can look out for alternate angles, we can look out for corresponding angles, we could look out for co-interior angles. Now in this case, I already see that the letter F here is being formed, which means that that angle that we're looking for is equivalent to the 112 that we found, because these two angles here are corresponding, and hence we have found what the missing value is. I haven't listed the steps, but I've mentioned them, so make sure in such instances you do indicate what your reasons were as well. Let's move on to the next question. You've been given a grid and you're being asked to draw the straight line with three equations: x equals 3, y equals 1, and x plus y equals 7. Additionally, they have told us to label each one of these lines. So let's get on with it. For the line x equals 3, you should know whenever x equals a constant, it is going to be a vertical line at where x is 3. So this is going to be my first line. So as I go about it, let's go ahead and label it. This is my line x equals 3. Y equals 1. Whenever y equals a constant, it is going to be a horizontal line. And so this is going to be my next line. Y is equal to 1. And in the last case, they're asking us to draw x plus y is equal to 7. So multiple ways of going about this. A lot of students prefer drawing a table. So we're going to draw a table, but first we're going to make y the subject of the formula. I'm going to move x onto the other side. So y is equal to 7 minus x. Then you draw a table of values and you pick any random values of x and then find the corresponding y values. So for instance, I pick 7, 5, and 0, any three random values. I substitute these into the equation that we formed. So the first one, we're going to be doing 7 minus 7, which gives me 0. 7 minus 5, which gives me 2. And 7 minus 0, which gives me 7. Thereafter, I'm going to go ahead and plot these points over here. And then I connect using a straight line. You don't necessarily need to pick the ones I picked. You could pick any random three values and then always extend your line based on the size of the grid. So there we've answered that question. Let's not forget to label this particular line over here as well. This was given as x plus y is equal to 7. Alright. The next question is telling us, show by shading on the grid the region that satisfies all three of the inequalities. All right. Now, in such questions, I prefer shading the unwanted region. So my first inequality says x is greater than or equals to 3. So that means I'm looking at values of x that are greater than 3, 4, 5, 6, 7, 8 in this situation. But remember, I'm shading the unwanted region, which means I'm going to shade to the left. We don't want anything that is less than 3. So that's my first one done. We apply the same thing to the next one. It's telling us y should be greater than or equals to 1. So we want anything that's above 1, but we don't want anything below it. So I'm going to shade out this region as well. Finally, x plus y is less than or equals to 7, which means I want all the values that are going to be smaller, but not those that are going to be larger. Again, I go ahead and I just shade my unwanted region. And after I have done that, you see we are left with a section that was unshaded. And that there is the region R that we were supposed to label. Okay, moving on to the next question. This one is asking us to expand double brackets. So in this instance, you can decide whichever of the two brackets you would like to start off with. Now, I noticed something in this particular question, and I noticed that these two are very easy for me to expand. So I'm going to choose to start off with these two. You don't necessarily need to do the same. So I'm expanding 3x minus 1, 3x plus 1. Now the reason I said these are very easy to expand is because I notice it uses difference of two squares. Remember, when you have a minus b and a plus b, it's very straightforward. You take the first term, you square it, you take the second term, you square it, and because it's difference of two squares, you're going to be having a minus there. If you don't want to apply that, you can still go ahead and expand the long way. It's going to give you the same answer, but let's apply this over here. So we agreed we're going to take the first term, we're going to square it, we're going to take the second term, we're going to square it, and we're going to subtract these. This gives me 9x squared minus 1. Now just to confirm, for those that don't regularly apply difference of two squares, had I done the other method, 3x minus 1, 3x plus 1, by expanding each one, I break open the 3x. I would have 3x plus 1. Then I have a minus 1 and 3x plus 1. If I expand this, I would have a 9x squared plus 3x minus 3x, and negative 1 times positive 1 gives me negative 1. Upon collecting my like terms, I would have 9x squared plus 3x minus 3x becomes 0, so I don't need to write that down, and minus 1 remains the way it is. So any of the two methods, I preferred using the shortcut. Alright, so remember we've only expanded the first and the last bracket. I still had to expand using x plus 2. So now this is what my question becomes. Now here I'm going to go ahead and expand using the method I showed in green. So 9x squared, and then I'm going to expand x plus 2, and then I have a negative 1 and x plus 2 again. Alright, expanding this gives me 9x cubed plus 18x squared minus x minus 2. A common mistake students make is when expanding out, they forget that this negative over here, this negative 1, is what applies to the whole of the second bracket. So you're multiplying this one by negative 1 and you're multiplying this one by negative 1 as well. Then you check if there's any like terms, which there aren't in this case. That means we are done with this, and that is our answer. Okay. Proceeding on to the next question, we have an algebraic fraction that they are asking us to simplify. Now, whenever you have a negative power, you can start by making it positive simply by reciprocating what you have inside the bracket, right? So I start by reciprocating what I have inside the bracket. So 8xy squared becomes my numerator, and my denominator now becomes 2x power 5. Because I have reciprocated this, my power now becomes a positive power. This is what I have. Now, because this power is outside the bracket, remember, it applies to everything inside the bracket, which means each and every term is going to be affected by it. So I start by raising 8 to the power 2. 8 raised to the power 2 gives me 64. X raised to the power 2 gives me x squared. And then y squared raised to the power 2. Remember, whenever you have a power raised to another power, you need to multiply the powers, which gives me power 4. I do the same thing for my denominator. I start by raising 2 to the power 2 to give me 4. X to the power 5 raised to the power 2. I'm multiplying my powers, and so I will have x power 10. Now remember, the question expected me to simplify fully. So you could have decided to simplify before working on the brackets. For instance, you could have done 8 divided by 2 to give you 4. You could have simplified the x's as well, but I didn't see that earlier, so I can go ahead and simplify it now. 64 and 4 are divisible, leaving me with 16. And because I have x as a base over here, and the base in my denominator is larger, I will remain with x in the denominator. I simply subtract 10 and 2 to give me 8. And that there is my final answer. It cannot be simplified any further. Okay, moving on to the next question. The curve C has an equation y equals 4x cubed plus x squared minus 20x. Find dy over dx. They are asking us to differentiate this. Differentiating, very simple. You start by multiplying the power with the coefficient. So I'm going to start off by doing 4 multiplied by 3, giving me 12. And then x, after having multiplied the power and the coefficient, you subtract 1 from the power. And so it becomes power 2. I do this same steps for all the terms that we have. The next term is x squared. The coefficient here is 1. So I'm multiplying the power with the coefficient. 1 times 2 giving me 2. And remember, we need to subtract 1 from the power. The power is 1. I don't need to write that down. The next one, the power here is 1. A negative 20 multiplied by 1 will be left with negative 20. And then x raised to the power 0. Now remember, anything raised to the power 0 is equal to 1, which means this must have been equal to 1. And 20 multiplied by 1, negative 20 multiplied by 1 still remains negative 20. And there we have answered that question. The following question, a continuation of what we've just done above, find the x coordinates of the points on C where the gradient is 4. Remember, dy dx refers to our gradient. So what we're going to do is, whatever we had as our gradient, 12x squared plus 2x minus 20, we're going to be equating it to 4. Now I see we have a quadratic. Remember, whenever we are trying to solve a quadratic equation, it needs to equal to 0. So what I'm going to do is I'm going to take my 4 cross onto the other side. I'll have 2x minus 20 minus 4 is equal to 0. Now we go ahead and collect our like terms. I would have 12x squared plus 2x, and negative 20 minus 4 gives me negative 24. So a common mistake I notice students make is they look at this as 20 minus 4 and write it as minus 16. But remember, whenever you look at a term, you look at it with the sign that comes before it. So this is not 20, it is negative 20. Negative 20 minus 4 gives us negative 24. Okay, now that we've equated it to 0, you use a method of your choice to solve the quadratic. You could decide to use the product sum factor method, the factorization method, if you're able to find factors, or you could use completing the square, or you could use the quadratic formula. So I'm going to use the quadratic formula. To use the quadratic formula, you just need to know what your a, b, and c are. In this case, our a is 12, our b is 2, and our c is negative 24. We're going to use that long formula that's always provided in the booklet. Negative b plus or minus the square root of b squared minus 4ac. And all this is over twice a. So this is what I have. Now you could decide to just punch this into your calculator if your calculator types fractions, or you could go piece by piece by starting to work out what we have inside the root. And when I do that, I will have, this still remains negative 2 plus or minus, that is going to give me 1156 divided by 2 by 12, which gives me 24. I go on and look for the root of 1156, and that gives me 34. Oops. 34 divided by 16. Now the reason I'm writing the plus and minus, remember we're going to be getting two solutions whenever you're dealing with a quadratic. And so I'm going to do negative 2 plus 34, then divide it by 24, and negative 2 minus 34 and divide it by 24. Upon doing that, I will find my two solutions. X is 4 over 3, or X is negative 3 over 2. And feel free to write these as decimals. I preferred not to write the first one as a decimal because I was getting a recurring decimal. But no harm in writing them as decimals either. Alright, moving on to the next question. Ali uses a fitness tracker to count the number of steps he walks each day for 7 days. For the first 4 days, his mean number of steps is 11,800. For the next 3 days, his mean number of steps is 13,207. Work out the mean number of steps for the 7 days. Alright, now, something to keep in mind, this is a combined mean question. Ask yourself, how do we calculate mean? So we know mean is gotten as the summation of x divided by n, which refers to the total number of values you're looking at. So if you're looking at the first one, we don't know the total number of steps he walked. Okay, so we don't know the total number of steps he walked, but we know the number of days, which is given as 4, and the mean that it produced is 11,800, which means I can take this 4 across onto the other side and solve to find the total number of steps for the first 4 days simply by multiplying. And this is going to give me, oops, sorry about that. This is going to give me 47,200. I do the same thing now for the next 3 days. So this time round, we're going to be dividing it by 3, and it's supposed to give us 13,207. Again, I'm going to multiply 13,207 by 3, and that is going to give me 39,621. So we know for the first 4 days the number of steps he walked, and the next 3 days the number of steps that he walked. So in the 7 days, the total number of steps that he walked, I'm just going to add these up and I'm going to get 86,821. Okay. Because I'm calculating mean, I need to take this sum and divide it by the total number of days, which we know is 7. So I just take this, divide it by 7, and I find my mean to be 12,403. All right, great. Moving on to the next question. A is the point with coordinates -5, 12. B is the point with coordinates 19, -48. You're being asked to find an equation of the straight line that passes through points A and point B. Right. Whenever you're dealing with the equation of a line, we know equation of the line is given in the form y is equal to mx plus c, where m refers to the gradient and c refers to the y-intercept. So let's start by working out what our gradient is going to be. Gradient is gotten as change in y, so y2 minus y1 over change in x, so x2 minus x1. All right. So I'm going to be doing 12 minus -48 and -5 minus 19. So I've just picked the coordinates from the question. When I do that, I'm going to get 60 as my numerator and -24 as my denominator, which then just simplifies to -5 over 2 or -2.5, however you like to see it. All right. I have found my gradient, so I can come back here and input it into my y equals mx plus c, -5 over 2, x plus c. To find c, plug in any one of the two coordinates that have been provided. So let's suppose I want to use -5, 12. Remember, this is my x coordinate and this is my y coordinate. So in place of y, I'm going to be putting in 12. And in place of x, I'm going to be putting in -5 plus c. All right. Working this out gives me 12 is equal to 25 over 2 plus c. To find c, I take this across onto the other side, which means I'm going to be subtracting, and that is going to leave me with -1/2. Finally, just put it back into the form y equals mx plus c. So y equals to -5 over 2x minus 1/2. Once again, it's not necessary for you to write it in terms of fractions. You could decide to write it in terms of decimals as y equals -2.5x minus 0.5 or any equivalent form. Okay, moving on to the next question. You're being asked to complete the table of values for y equals x cubed minus 3x plus 1. All I'm going to do is substitute each one of these into that equation. So for instance, for the first one, y is equals to, I'll put -2 in place of x cubed minus 3 again into -2 plus 1. So all I've done is I've replaced my x's with this particular value. Upon doing that, I'm going to get this to be -1. Now I repeat the same. This time round, I'm going to be substituting -1 because my next value is -1. I'll substitute, I get 3. I repeat the same steps for all of these. When I substitute 0, I'm going to get 1. And when I substitute 2, I'm going to get 3. Done. The next one is asking us to plot these values onto a graph. So I'm going to try and plot them here. -2, -1 is our first coordinate, which is here. -1, 3 is our next coordinate. 0, 1, 1 goes with -1 and 2 goes with 3. Those are my points that we found on the table. Now I know this is a cubic curve, so I need to connect these and try making your curve as smooth as possible. You won't be penalized if it's not very smooth, but just try your best to make it smooth. And there we have our curve. Okay, great. Let's proceed on to the next question. Here are 4 graphs. Write down the letter of the graph that could have the equation y equals to -1 over x squared. So you should be able to identify graphs of quadratic equations, linear equations, cubic equations, reciprocal graphs, and so on. So if I look at the first graph a that has been given to me. This one you should know is in the form a is equal a over x. This one is the negative reciprocal, so negative a over x. Looking at this one over here, it's a over x squared where it's a positive, and over here it's negative a over x squared. Because I'm dealing with a negative, I know that this must be b. Perfect. Okay, let's proceed on to question number 15. We have a recurring decimal 0.68818181, and you're being asked to use algebra to show that it's equivalent to 15 over 22. So let's see how we're going to go about this. So first of all, we just let x be the decimal that they've given us, 0.6. It's the 8 and the 1 that are recurring, so 81 as many times as you want to write it down. Now you have to find a pair of values that would have the same digits after the decimal. So for instance, what we do usually is find 10x, 100x, 1000x. You eventually get the hang of it, so you don't have to look for all of them, but let's go about it. I'll start by multiplying it by 10, which means I'm moving my decimal one place ahead. I have 6.818181, right? I cannot use these two because the digits after the decimal are not the same. The goal is to make sure the digits after the decimal are the same. So I continue looking for another one. I'm going to do 100x, which is going to be 68.181818. Again, not the same. I look at 1000x, which is going to be 681.818181. All right. Now you see that the digits here, 818181, are the same as the digits here, 818181. Again, I could just go on and on. But they are the same after the decimal, which means I am going to be using these two. So I'm going to be using 1000x and I'm going to be using 10x. All right, so just bring those over here. 681.818181 again as many times as you want to write it down, and 6.818181. Now I go ahead and I subtract these two. So when I subtract 1010, I would be getting 990x. And because these digits after the decimal are the same, ideally what's happening is that they're cancelling each other out. So we're doing 681 minus 6, which is going to give me 675. To find x, I need to take 990 onto the other side, which means I'm dividing it by 990. And if you go ahead and simplify this, you're going to end up with the 15 over 22 that they asked us for. So hence, we have proved this. Okay. Moving on to the next question. Prove that the difference between two consecutive square numbers is always an odd number. Show clear algebraic working. Alright, so two consecutive square numbers. Now because I'm just dealing with consecutive numbers, so you should know when you're dealing with consecutive numbers, you're looking at n plus 1, n plus 2, n plus 3. You can pick any. So what I'm going to do is I'm going to pick the first two. I'm going to work with these. And remember, we're looking for square numbers. Alright? And then we're looking for the difference between them. So because I'm looking for square numbers, I'm going to square these. Remember, you can use any one of these, any two consecutive ones. I'm just going to work with the first two. So I'm doing n plus 1 squared minus n squared. When I expand this, again, a common mistake students make is they decide that they're going to square every term in the bracket. So they write n squared plus 1. This is not correct. There is an addition in between, so you need to be very careful in situations like this. This is asking you to expand double brackets where you have n plus 1 and n plus 1. Alright? So when you expand those, you're going to be ending up with n squared plus n plus n plus 1, and you have a minus n squared. You go ahead and collect your like terms. N squared and n squared becomes 0. N plus n, 2n plus 1. And there we have shown that it is an odd number. So remember, because of this plus 1, it's proving that it's an odd number. If you're left with just 2n or 2n plus 2, 2n plus 4, then those are all even numbers. Okay, let's proceed on to the next question. Question number 17. A total of 80 men and women took part in a race. The cumulative frequency graph gives information about the times in minutes they took for the race. So the curve has been drawn for us in this case. The question is asking us to find an estimate for the interquartile range. Now remember, interquartile range is gotten by finding the upper quartile, which we call Q3, and the lower quartile, which we call Q1, and subtracting these two. The upper quartile is always 3/4 into the data, and the lower quartile is a quarter way into the data. So in this case, because the cumulative frequency graph is drawn, you come to your curve and see where the highest value is. And the highest value here is at 80. So we're going to take each one of these and multiply them by 80. This is going to give me 60, and this is going to give me 20. Now that's not my upper and lower quartile. What I need to do is go back to my curve and take the reading at where the cumulative frequency is 20 and where it is 60. So let's start off with the 60. So what I'm going to do is I'm just going to connect this. I want to read the value that it gives me, and I see that the value that it is providing me with is 56. So that is my upper quartile, 56. And I need to do the same thing for where it's meeting at 20. So I come here and I read the value at 20, and this is going to be giving me 38. So that means my upper quartile is 56 and my lower quartile is 38. When I subtract these, I will be finding my my interquartile range, which in this case is going to be 18. Okay, moving on to the next question, which is telling us 60% of the men took 50 minutes or less for the race, and no women took 50 minutes or less for the race. So all the men finished within 50 minutes. 60% of them, finished within 50 minutes. The question is asking us to work out an estimate for the number of men who took part in the race. So I'm going to work with the 60% who took 50 minutes or less, because we know there's no women involved over here. So I'm going to come back to my curve at where we have 50 minutes. So anybody that took less than 50 minutes is a man. No woman took less time than this. So I'm going to come here and I'm going to take the reading that it provides me with. So when I look at this is at approximately 42. So I know that 60% is represented by 42 men. We want to find out the total number of men, so we're going to find out what 100% is. Simply cross multiply 100 by 42 divided by 60, and that is going to give me my answer to be 70. So this means 70 men took part in the race. Okay, moving on to the next question. The total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. So again, I see it's a word problem coming up. So I'm going to go ahead and try coming up with anything I can get along the way. Okay. So these are formulas that are provided, and the surface area of a solid hemisphere. You provided with the formula for the surface area of a sphere, which is 4 pi r squared. Now remember, because we are dealing with a hemisphere, that's half a sphere, I need to divide that by 2. So when I do that, I'm going to end up with 2 pi r squared. Now again, a common mistake that students make is that they ignore this particular word over here, the total surface area. When you're dealing with a hemisphere, it has two faces, not only the curved face, but the face on the top as well, which is a circle. So we need to add the circle, which is pi r squared. So if I'm looking at the hemisphere, the total surface area is going to be gotten as 3 pi r squared. All right. Now you're being told the total surface area of the hemisphere is equal to the total surface area, the curved surface area of a cylinder, and that one is gotten as 2 pi RH. Okay, that's my first piece of information used. Then it's telling me the radius of the hemisphere is r. Okay, great, we're not changing that. But the radius of the cylinder is twice the radius of the hemisphere, which means in place of r, I needed to have used 2r in this particular situation. That is my second piece of information, giving that out. Okay. Now I can go ahead and try and clean this up before continuing to read the rest of the information. I have 3 pi r squared is equal to, I expand this and I will end up with 4 pi RH. I can try and clean this up because we have pi on both sides. I can cancel out the pi. I have r squared over here, which means I have 3r is equals to 4rh. I can cancel out one of the r's on each side, and that means I will be left with 3r is equals to 4h. I'm going to keep that on one side. I'm not sure when I'm going to use that again, but let's continue with the rest of the information. We haven't read through the whole thing. You're being told that the volume of the hemisphere to the volume of the cylinder. So let's come up with the formulas that are provided. Volume of a hemisphere is 4 over 3 pi r cubed. That's for a sphere. Then we need to divide that by 2 because we're dealing with a hemisphere. When you simplify that, you're simply going to get 2 over 3 pi r cubed. Volume of a cylinder is gotten as pi r squared h. Something to keep in mind over here. So I could leave this like this just for working sake. Something to keep in mind over here is that the radius was twice the radius of the hemisphere. So we're supposed to be using 2r here as well. Okay. Again, I'm going to try and clean this up. I'm going to be having 2 over 3 pi r cubed is to 4 because 2 squared, and then r squared h. Okay. Again, I have a ratio here, which means I can go ahead and clean up. I can cancel out the pi's on both sides. This here tells me there's 2 r's. This here tells me there's 3 r's, which means I can cancel out 2 of them. And this is what I'm going to be ending up with. I have 2 over 3r is to 4h. Now, I cannot simplify any further, but I can substitute based on the first pieces of information. If you remember what I have on the side of my screen, 4h is equal to 3r. So I can come here and in place of 4h, I can indicate 3r. This is what I have. Now that I have a r on both sides, I can cancel these out. And that is what I am left with. Now moving on back to the question wanted it in the form 1 is to m. So to find m, I'm simply going to cross multiply this multiplied by this divided by this. So 1 multiplied by 3, which gives me 3, divided by 2 over 3, which is now going to give me 4.5. And that there is my solution. 4.5 or 9 over 2, however you'd like to see it. Okay, great. Making good progress. Let's move on to the next question. You're being asked to solve the inequality 10x squared plus 11x minus 21 is less than 0. Okay, so the first thing you're going to do is you're going to pretend this is a quadratic equation and solve it in the normal way that you would solve it using a method of your choice. I'm going to decide to use the quadratic formula again. So we need to know what a is, which is 10, b, which is 11, and c, which is negative 21. I'm going to substitute it into my formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Again, you can decide how you want to go about working this out. I'll start by working out what's in the root, and that is going to give me 961. So this is divided by 961. Apologies, this is negative 11, not 1. And this is going to be divided by 20. I work out the root of 961. Oops, sorry about that. I work out the root of 961, and that gives me 31. And now I work out each one of these, and I will find my two solutions. One of the solutions is x is equals to 1.5, and my second solution is x is equals to negative 2.1. Now remember, because my question was in terms of an inequality, my solution is also going to be in terms of an inequality. So how do we find out what is the region that we are being asked to look for? So one of the ways in which we do this is by sketching the curve. I know it is a quadratic curve and it is a positive quadratic curve. You look at the coefficient of a, you look at the coefficient of x squared, which is a. It's 10. It's a positive number, which means this is going to be the shape of the curve. I'm just drawing a sketch. This here is negative 2.1 and this here is 1.5. The question wanted us to look at the region that is less than 0, which means I'm looking at the bottom half, which is a closed region. Therefore, my solution is going to be lying between negative 2.1 and 1.5. And that's all you needed to do. On the flip side, if the question said the region greater than 0, it means I'm looking at the region above, and I would give two answers. X is less than negative 2.1 and x is greater than 1.5. But that wasn't our question, so we're going to just erase these from here. Okay, let's move on to the next question. B and C are points on a circle with a center O. AB and AC are tangents to the circle. Angle BAC is given as 40 degrees. Let's just mark that in. This one is 40 degrees. Work out the angle BOC. So I'm just going to connect what they've asked me to find. They want me to find angle B or C. And they're asking us to give reasons for each stage of our working. Okay, that is the angle we're looking for. This requires me to use circle theorems. You should know that the radius to the tangent meets at a 90-degree angle. So I can mark this as 90 and give my reason. Radius to tangent meets at 90 degrees. Then we see that this shape that we have over here, BOCA, is a quadrilateral. And we know that the sum of angles in a quadrilateral is always going to be 360. So what I'm going to do is I'm going to take what I already have and subtract. So minus 40 minus 90 minus 90. And when I do that, I'll be able to find my angle to be 140. Because angles in a quadrilateral add up to 360. And that there is our solution. Okay, moving on to the next question. The diagram shows a cuboid ABCDEFGH, whereby EH is 9 centimeters, HG is 5 centimeters, GB is 6 centimeters. They're all marked for us. Work out the size of the angle between AH. So I'm going to just connect my A to H and the plane EFGH. So I'm just going to form my right angle triangle over here and mark in the angle that they've asked me to look for. So I'm looking for this particular angle. Now when you're dealing with triangles, and remember this is a right angle triangle, you need to have two pieces of information. On this particular triangle that we have drawn so far, I only have one piece of information. I know the length of BG was given as, or GB was given as 6, which is the same as this particular length over here. So I need to find any other side. Some people would want to look for this particular length over here. So if you were looking for the length of AH, then what you're going to do is you can use 3D Pythagoras theorem, whereby you'll be doing 9 squared plus 5 squared plus 6 squared. This would give us AH squared, and then once you find your solution, you're going to square root your answer, and that is going to give you the square root of 142. That's one way of going about it. Somebody else could have decided that I don't want to look for AH, I'm going to go ahead and look for FH. So how are we going to go about that? So if you were looking for FH, you do see that the base also forms another right angle triangle over here. So I'm using this particular side, and the hypotenuse. This was given as 9 and this is given as 5. Again, I can apply Pythagoras theorem. If I was looking for FH squared, I would be doing 5 squared plus 9 squared. and therefore FH is going to be the square root of 106. So you can decide whichever two you want to work with. It doesn't matter. We have all three sides. All right. So I'm just going to redraw my triangle over here. We had the 6 that was given, and let's assume I'm working with the 106. The question wanted me to look for this particular angle here. It's a right angle triangle. I can use SOHCAHTOA, which means I need to start by labeling my sides. This here is my opposite, and this here is my hypotenuse. This here is my adjacent. I have my adjacent and I have my opposite. We're not going to bother with the hypotenuse unless obviously you were using the square root of 142. And because we have O and A, which means we're going to be using TOA, we are looking for the angle. So whenever you're looking for the angle, this time we're using 10, we'll be doing the inverse. The opposite, which is 6, over the adjacent, which is the square root of 106. So this is what I'm working with. I just use my calculator and get my answer to be 30.2. And that is that question done. All right. Moving on to the next question. The Venn diagram shows information about the numbers of items in set A, set B, and set C, where x is an integer. Given that the number of elements in A union B complement is equal to 26. So first, let us identify what A union B complement refers to. So if I'm looking at A union B, I'm looking at everything that is in A and in B. But because I'm being told it is the complement, it means I'm left with these things over here. So it is telling me that 5x plus 3x plus 2 is going to equal to 26. That means I can solve for x. I collect my like terms. 8x plus 2 is equals to 26. 8x is equal to 24, which means x must equal to 3. Okay, so I've found that piece of information. The question is asking me to find the number of elements in A complement intersection C. Now, such questions often tend to confuse students. Very easy to go about it. It's telling us A complement, so I'm going to identify what I have in the complement of A. So everything that's not in A, there is the 4x, 2x, 5x, and 3x plus 2. And then it is telling me intersection C. So now I look at everything that's in C. This is in C, this is in C, this is in C, and this is in C. Because the question was looking at the intersection, it's what's common between these two. If it was the union, I would be taking everything that's underlined. But because I'm looking at the intersection, I'm looking at what is appearing on both. So which one has the double lines? It's the 5x and the 2x. So I'm going to add 5x plus 2x, and that is going to give me 7x. But remember, we already found x to be 3. So I'm going to substitute 3. And 7 by 3 gives me 21. And that there is my answer to this question. Okay, let's move on to the next question. A and B are two similar solids. A has a volume of 1836. B has a volume of 4352. You've also been given the total surface area of B to be 1120, and it is asking you to work out the total surface area of A. So this here is similar shapes. You have been given the volume scale factor, which is 1836 to 4352. This is the volume, okay? You need to find surface area. So what we're going to do first is we're going to look for the length scale factor. To find the length scale factor, you need to cube root this. Now, an easy way to remember is that volume is a cubic unit, right? So I'm going to start off by cube rooting this. So I have 1836, it's the cube root, and the cube root of 4352. That is the length scale factor. The question wanted me to find the area. So I need to find the area scale factor as well. Area scale factor? Area is a square unit. So I'm going to take my length scale factor that we found here, and we're simply going to go ahead and square these. because area is a square unit. So I'm just going to bring this down here and I'm going to go ahead and square this. Then I had been given the total surface area for B to be 1120. So I'm going to put this down here, and to find this missing value here, I simply go ahead and cross multiply this multiplied by this divided by this here. And when I do that, I will find my answer to be 630. So you could decide to cube root each one of these along the way if you didn't want to write with the signs, but I prefer not to, because the cube root of 1836 is going to be 12.24496531. I don't want to skew my answer, so I'm just going to leave it the way it is and work with it that way. Okay, moving on to the last question of this particular, not yet the last question, sorry. Moving on to question number 24. You're being asked to express this particular fraction. You're expressing this particular expression as a single fraction in its simplest form. Now, whenever you're given a question like this, you're going to start by factorizing anything that can be factorized. So I'm going to look at this particular numerator over here, and I'm going to factorize this using difference of two squares. So previously we mentioned when you have a plus b and a minus b, you can expand it by doing a squared minus b squared. So the reverse can apply over here. What I'm going to do is I'm going to take the square root of the first term, which is going to be 3x, the square root of the second term, which is going to be 2. I have two brackets of these. One of them is going to be a plus 2, the other one is going to be a minus 2. That's my numerator done. Moving on to the denominator of the same bit over here, we can factorize this by looking for the product, sum, and the factor. Product is gotten by a multiplied by c, which is 3 multiplied by negative 10, giving me negative 30. The sum is negative 13, and my factors are two numbers that I can multiply to get negative 30 but add to get negative 13. So I'm going to be using negative 15 and 2. Right. Now I come here and replace my b term with the factors that I found. So I'll be having 3x squared minus 15x plus 2x minus 10. Then I factorize in parts. I look at the first two terms, find out what's common. 3x is common. I'll be left with x minus 5. I look at my second two terms, what's common. 2 is common. Again, I'll be left with x minus 5. Remember, what's in the brackets must be the same. If they're not the same, then we may have made a mistake with our factors. Now that it's the same, I know this is going to become 3x plus 2, x minus 5. There's nothing else I can factorize, so I'm just going to bring back my question over here. I have 1 over 3x minus 2 multiplied by, my first numerator was 3x plus 2, 3x minus 2, and my denominator, we just found it to be 3x plus 2 and x minus 5. So remember, because I'm using BODMAS, I'm going to start off with these. I haven't used the minus 7 over x minus 1 yet. I'm going to try and clean this up first. Because I am multiplying, I am allowed to cancel. This and this is common. I can cancel it out. This and this is common. I can cancel it out. If I work this out, I'm going to be left with 1 over x minus 5. Now remember, we haven't considered the third part of the fraction, which was 7 over x minus 1. As we said in the very beginning, when you're adding fractions, the denominator must be the same, and the same applies when you are dividing fractions. So I'm just going to be using the butterfly method. I'll multiply this by this and this by this. So I'm multiplying 1 by x minus 1 minus 7 into x minus 5. And then I also multiply my denominators by each other. X minus 5, x minus 1. I go ahead and expand my brackets. When I expand my brackets, I will have x minus 1 minus 7x plus 35. Remember, two negatives make a positive. And this is going to be over the denominator that we found, which is x minus 5 and x minus 1. I don't need to worry about expanding my denominator. It's not going to earn me any marks, so I'm just going to leave it the way it is. My numerator, however, can be simplified. I can work out my like terms. X minus 7x gives me negative 6x, and negative 1 plus 35 gives me 34. And once again, my denominator would just stay the way it is. And there we have it. Okay, moving on to the next question. You're being asked to express 2x squared minus 12x plus 3 in the form a into x plus b squared plus c, where a, b, and c are integers. So basically this question is asking you to complete the square. So whenever we're completing the square, we use a formula, x plus b over 2 squared minus b over 2 squared plus c. So this is what we're using now. Just a disclaimer, when you're using this particular formula, you need to ensure that a is equal to 1. The coefficient of a needs to be 1. And in this case, the coefficient is not 1. So what are we going to do? I'm going to start by plugging out the 2 outside and factorizing everything. So x squared minus 6x plus 1.5 or 3 over 2, however you want to look at it. This is what I'm working with. Now I'm going to ignore that 2 and I'm going to plug everything into the formula that I provided up above. So x plus b over 2, so negative 6 over 2, and then squared minus again negative 6 over 2 squared plus 1.5. I'm going to clean this up. This gives me x minus 3 squared minus negative 6 divided by 2 is negative 3. When I square it, I'm going to get 9 plus 1.5. Again, I clean this up, x minus 3 squared, and this is going to give me minus 7.5. Now remember, in the beginning we had plugged out the 2. You ensure that you carry it down all through, and you go ahead and you're going to expand the bracket in the very end. So when I expand this, 2 remains 2, x minus 3 squared. Do not expand the first part, but you can expand the second part. 7.5 multiplied by 2 would give me 15. And that is my solution. Okay. Now, in this next question, you've been given the curve with the equation y equals 2 into x plus 4 squared minus 12 into x plus 4 plus 3. And you're being told M is the minimum point on C. Find the coordinates of M. Now, this is a continuation of the first question. So what you notice over here, in comparison to what you originally had, in place of x, what they're doing is that they're placing x plus 4. So if that was the function of f of x, they are now giving you the function of f of x plus 4. This is now leading you to graphical transformations. This is simply telling you that you are dealing with a translation. Remember, because it is inside the bracket, it is affecting the x coordinate, and it means you're moving 4 units to the left. So I know that's what I'm supposed to be doing. But to find the coordinate, I would first need to know the coordinate of the turning point in the initial equation, which I can find using this here. Those are the coordinates of the turning point of the original curve. Whatever's in the bracket, you negate. So this becomes a positive 3, and outside the bracket remains the same, which is a negative 15. Now I am going to translate it 4 units to the left. It is affecting the x coordinate. This is moved 4 units to the left. So I'm going to be doing 3 minus 4, which gives me negative 1. Negative 15 remains the way it is. And that there is our solution, negative 1, negative 15. Okay. Now the last question of this paper. You're being asked to simplify this and give your answer in the form 5 to the power w, where w is an expression in terms of x, and you're being asked to show each stage of your working clearly. So what we do in such a situation is we start by writing every number as a product of its prime factor. So let's start off with 30, right? 30 can be written as 2 multiplied by 3 multiplied by 5. That's the first term there. Multiplied by 25. I know 25 can be written as 5 times 5, or I can just say it's the same as 5 squared. And remember, there was already a power there, 2x plus 7. So that's the numerator done. I'm going to work out the same thing for the denominator, the square root of 180. So I start by writing 180 as a product of its prime factors. 2 squared times 3 squared times 5. I've just used my calculator to get this. Because it's the square root, I know this can be raised to the power a half. Again, for the next one, it is the square root of 5. So this is 5 raised to the power a half. And then it has another power of 4x plus 9. Now, I try and clean these up. So, my numerator, still 2 times 3 times 5. We're not going to multiply them out. Remember, when you have a power raised to a power, we multiply the power. So I'm multiplying 2 multiplied by 2x plus 7, which gives me 4x plus 14. That's there. That's my numerator done. And now I work on my denominator. Everything is raised to the power a half. So I'm multiplying 2 times a half, which gives me 1. 2 times a half again, which gives me 1. That's where the powers are going. And 5 raised to the power a half. Now I multiply out the second part. This is going to give me 2x plus 4.5. Okay. Now I can decide to clean this up a little bit by cancelling out the 2's, they're common, cancelling out the 3's, they're common. So you already see that it is coming together because we had to express it in the form 5 to the power w. So I'm now going to work on my numerator. This is the power 1. Because I am multiplying, remember we are adding our powers. When I add my powers, I'll be left with 4x plus 15. And I do the same thing for my denominator. I will have 5 power 2x plus 5. Okay. Now, I am dividing. My base is the same, which means I can subtract my powers. So that's what I'm going to do. I have my powers and I'm going to subtract these powers. So 4x minus 2x gives me 2x, and 15 minus 5 gives me 10. So that there is going to be my power 2x plus 10, which means w that they wanted me to find is just 2x plus 10. And that brings us an end to the end of this particular paper. Alright, if you found this video useful, please feel free to subscribe. I'll be posting more walkthroughs whenever time allows, and I'll see you in the next one.